and the result is also a negative sign. So look at the table there. When you have this, your overflow result will be what? Your source is negative. Negative sign, that sign is a sign. Your destination is negative sign. Your result is negative also, which is here anything positive or negative, then your V will equivalent to 0. So you have to refer to the table. Okay, another one. Let's try another one just now. You have the negative just now. Try back again this one. Try again this another one. This is for additional process. Add, we change to 44 and 88 again. 44 and 88. What flag did change? What bit have been set? And 88. D0 plus D1. Now the process say what? 44 plus 88. This is equivalent to 44. 44 means 0, 1. 0, 1, 0, 0. 0, 1, 0, 0. Plus 8 is 1000. 1000 here. And your result is 0, 0, 0, 1, 1. I'm making fast, eh? This is binary numbers, eh? Alright. And negative, n is set to 1, right? Because of your result now is MSB is 1, it's a sign negative. But now look at the sign. This is a positive sign plus negative sign resulted in negative. So look at the table for additional on the overflow. Your V is equivalent to on the table. The slide say what? For the app, you have to look at this table. So they have different table for the subtraction and addition. So now it's positive, negative, and the result is negative. So which one is source, which one is destination? Just now is D0, D1, right? Destination is D1, right? Or do I have problem? D1 is destination. Okay. So D1 is destination. Destination is D1. D1 is negative, is it not? D1 is what? D1 is 88. This D1 is 88, right? D1 sign is negative. Destination, right? So negative here plus positive resulted in negative or positive. Your V is always equivalent to 0. Faham? So let's try another number. Change 88. Alright, try this one. Change the last two to AA and BB. Change again the code here for the additional AA and BB. Then run again your code. Look at the answers. AA and BB. Look at the status register now. What does it change? Which registers have been changed to set? So now you have your overflow, now is 1, right? Your copy is 1 because your carry is 1 because of course is a number. So X is copied from Z. So how does it do 1, 1? So look at the add table again. Add table again. Go for, look at the overflow add table again. Look at the table again for the overflow. Now it's AA plus BB. AA means 10, 10, 10, 10. B means 1011, correct? If I'm wrong, you have to let me know. 1011. 01, 11, 0, 0, 0, 1, 1, 0. Do I have the same result or not in the calculator? Please check for me. Correct? Okay, what does it mean right now? So we have to look again on the results. The result for the MSB is 0. So your M is equivalent to 0. Right? Your Z is still equivalent to 0 because the result is not 0. Your carry is equivalent to 1 because there is a carry number. Your X is copied from carry. Now the V is the one that you need to find out. Look at the sign again. This one is a negative sign. Not a negative number, it's a negative sign only. Negative sign resulted in positive sign. So look at the table for the additional on the overflow B bit. In the slide you have to look at the table. So for add overflow, the sign say destination over here, the cost, of course, destination and source is the same one, right? So it's negative, negative, and the result is positive. So which one? Negative and negative. The result is positive. Your V will be equivalent to so I have all the one over there. You got the same result or not? I think so, okay. I think so. At the moment, I have not decided yet. Yes. Sorry? I have not decided whether I want to put this table or not in the final exam. I have not yet decided. But of course, it will be out in final. So far, do you guys understand for the status registers function? It gives you the status after you run any code, any lines. This is very important when you want to do your programming side. Because when you want to do the programming, you have to look at the status register before you can execute another thing. It's the process of debugging that's why you need to look over here. Any questions? So I have covered all these 5 register, these 5 bits for this register, status register. Any questions? If there's no question, means you understand. Delay in Arduino or C++ is very simple, just for delay, right? Wait something, then you wait something. Microprocessor, you cannot do that. You have to really go deeper to calculate the time, how long it executes. Yeah, that's the case. Some of them will let check. You will check the bit of that, you will check, then you will the function. So it's different. Yes, there will be. Especially on the computer, you are looking at this one chapter. So, any questions? Means I cover everything, so we have to go for tutorial, which is very important too. Any question? No? Faham? Faham belakang? Boleh faham? Alright, we understand. So, that's for the topic for this status. Oh, before that, we just need to look at the Boolean counter. Another one. This is also another important register that we need to understand. So far I do cover the data register. I also covered at the address register. Only A7 is not yet. A7 is one chapter. It's a stack pointer. Then I cover this one already. Now I want to cover this one. Program counter. So the definitions of program counter. So listen. So you know data register, again I repeat this thing. Data register done, address register done, stack pointer is one chapter. Alright, program counter, now, status register, you just now learn about that one. So what is the meaning of program counter? Dalam bahasa Melayu, very simple je dia kata. Counter is what? Kira is count. Counter is what? Pengira. Count is kira, pembilang pembilang. So dalam bahasa Melayu is dia kata pembilang program. So it's a program counter. What does it mean? Dia kata program counter contains, program counter contains the address of the next instruction to fetch and execute. So what does it mean? Program counter will tell you the current situation, where is your memory need to be executed. You have your whole bunch of program, right? So every program must look at the program counter before it can execute. So let's run one program here. Okay, let's do just add one, just anything sub.log G1. Just do it, anything, any number, doesn't matter. I just want to show you the okay, compile it. Just any number. Okay, once you compile, you have this window, which is very informative window. Okay, so now you have your data register over here again, your address register, your status register. 5 only I care, the rest I don't really care, I don't want to see. Then you have this stack pointer, hold on that one. You have this program counter. PC means program counter, pembilang program. So right now, the value over there is what? The value at the program counter is what? Yours, if you use my same program, you have the same number with me. The program counter is actually now at 1000. It stops over there. What does it mean? That counter is telling me that the next execution must be at address 1000. Your program now you store at 1000 here, correct or not? When you do your origin, you write your program, means you are storing your program at 1000 location. So here, when you move .long, this is the command 203C, the machine code. This is the value. 223C is the machine code for the move .long. This value, which is 1122. So now your command is pointing to this 1000. It does not yet execute. So if you want to execute, you will refer to this program counter, then it will execute. That's why you have to hit this line. You will go to the next one. You hit that one, look at this one. 6. My next program counter is 1006, which is referring to this one. It completes the syntax for this one, then you are pointing to this one. Program counter will point to the next location of the memory where it does need to execute the program. So when you hit again this button, it will jump to where? It will not jump here, it will jump to here. It will jump to 1000C here. This one is not yet executed, it's pointing only. So when you hit again enter, it will run that one, go for the next one. So means that program counter is always pointing to the locations of the memory where do you want to execute the program. It's pointing. Okay? Or confused? So it's always pointing to the next execution instructions. Okay, so far? Understand, right? So all this one is very important for you when you do your programming project. You have to look over here. Foreign counter is basically very automated. So you just need to write your own program that you know that where it does it. All this one is very automatic. You just need to look over here, and do all the programming stuff, the status register, test for all the cases. So any questions before we go for the tutorial? Alright, there's no question. So the lecture for that one completed already.